So today we are going to start endothermic reaction. Endothermic reaction. Endo, I told you that endo means absorb. Endo means absorb, and therm means heat. Okay, so the reaction in which heat is absorbed. Okay, so obviously delta H is positive for that reactions. This positive sign shows energy is absorbed. Okay, and negative sign shows energy is released, right? Okay, so then we are supposed to do characteristics as we did for exothermic change. Number one, container becomes cold. Container becomes cold. Number two, delta H is positive. Number three, energy of a reactant is lower than the product. Is lower than the product, right? Okay, so if we are going to, like, when we are going to make energy profile diagram, then you will be getting that why I'm saying that the energy of the reactant is lower than the product. Basically, energy is absorbed. It means that when something is absorbing energy, so obviously when it would be forming the product, so the substance would be having a higher energy. In that system, like we did in the last class, that was exothermic system. In that system, energy was released. So obviously reactant had higher energy. That this is the reason it has released its energy. So obviously when the product would be forming, so the product would be having a lower energy. But today I'm saying that the energy is being absorbed by the reaction. So obviously when it would be forming the product, as it absorbs some sort of energy, so obviously product would be having a higher energy, right? Okay, then energy profile diagram for endothermic system. Energy profile diagram. Energy profile diagram. So we have two diagrams. Okay, first one is without activation energy, then with activation energy. This is reactant. And this is the product. This is delta H, which is positive. So this is
Sir,
progress
can you
of
clear
reaction.
something up for me?
Sorry?
Sir, I have a question.
Hmm.
What is delta H supposed to mean again?
Enthalpy change, energy change.
Yeah, okay, okay, thank you.
Okay.
Thank you, sir.
This is energy. Okay. So As I told you, in an exothermic system, the direction of an arrow was downward, but today the direction of an arrow is upward. Upward means that it's going to gain energy, it's going to absorb energy. So remember, upward arrow, upward arrow means absorbed, absorbed, and downward arrow, released, released. Okay, so this is energy profile diagram without activation energy. Without activation energy, we have another energy profile diagram in which we would be showing activation energy. So if you remember, energy profile diagram for an exothermic system, I'm supposed to make it again because we have to do a comparison between the activation energy of endothermic system and also activation energy of an exothermic system. So if you can see this, just like that, this is okay. So this upward arrow shows energy change as energy is absorbed since the reaction is endothermic. And this arrow is representing activation energy. I'm supposed to draw energy profile diagram for an exothermic system for a perfect comparison. So as you can see this, uh, this is a reactant and this is a product. This was activation energy, EA. This was delta H, simple. This was delta H. So remember, if you can have a comparison between the arrows of activation energy for an exothermic system and for an endothermic system, if you can see, activation energy is quite higher for an endothermic system. Why? You know, endothermic system requires energy, they need energy, they have to gain energy. If you are not going to provide any energy to that systems, means that the reaction is not going to start. The reaction will not be starting until or unless you are providing energy. So that's why to start these reactions, they require higher energy as compared to an exothermic system. Let's suppose I'm giving you matchbox and I'm telling you that just ignite, just ignite, and then I'm going to like make a tea. Let's suppose I have given you dry matchbox, dry, okay, dry matchbox. And on the other hand, I have given you wet matchbox. What's the difference? Obviously, when you are going to ignite that wet matchbox, obviously it would be requiring higher energy. Why? First of all, it will have to dry, then it will be started to combust. Obviously. So this is the reason endothermic reaction requires higher energy as compared to exothermic systems. So that's why the length of an arrow, the length of an arrow will be representing the, you can say, the magnitude of activation energy. So I can summarize that activation energy for endothermic system, for endothermic system is higher than exothermic. Exothermic. Okay. Again, I'm going to summarize it for endo and for exo. For endo, for exo. Endo, delta H is upward, activation energy is upward. For exo, delta H is downward, but activation energy is upward. Remember, remember. Okay. So then I told you examples of an endothermic system, photosynthesis, and also the decomposition reaction, okay, etc. So that was all about endothermic system, right? Examiner would be asking in various ways. Let's suppose uh, I'm telling you that this is 10 kilojoules, right? And this is 50, you can say 30 kilojoules, right? So I'm asking what is the value for the activation energy that it would be needed to start. So obviously you would be subtracting like 30 minus 10. Obviously 30 minus 10 is going to give you 20. That is the activation energy that you need to provide. You need to provide that activation energy to the particular reaction to start. Okay. So this difference like the length of an arrow is going to represent that this much activation energy is supposed to be provided to the particular reaction to start. Okay. So he would be giving you different values and would be asking regarding this. Okay. So we need to plan accordingly. Then
Isn't the activation energy like 20,
yes,
30?
exactly. 30 minus 10 is 20. Like we have to find out the difference. Okay. We have to find out the difference, right?
So the difference
Yes.
is just the
Yes.
distance
Because
between the
yes, this
reactant
is zero.
product.
This is zero. So you need to subtract this area. Okay. You need to subtract this area.
Okay.
Okay. Okay. Then bond energy. Bond energy. Okay. Can anyone tell me what is bond energy?
The energy required to make or break a bond.
Yes. Good. So basically, this is energy released or absorbed. It is the energy released or absorbed. Let's suppose in the start of this chapter I told you every reaction has energy change. Every reaction has energy change basically. In terms of, you can say, I told you that the bonds of the reactant is going to be broken down, and obviously when they are going to form the new product, so the new bonds are going to be formed. This is the same for all reactions. I'm repeating. In reactants, remember, this is very important. Reactant bonds are broken. Bonds are broken. In the product, bonds are formed. Remember, when you are going to break down the bonds, so energy is needed. Energy is needed. Please mute. Energy is needed. And when the bonds are going to be formed, so the energy is released. Energy is released. Okay. So there is a difference. Kindly mute your mic, please. So there is a difference in energy. If you are Aryan, can you please mute your mic? Hello, Aryan. Okay, wait, let me do this.
I'm sorry, Mr.
Welcome, Salam. Can you please mute your mic, Aryan? Okay. Okay, then basically energy is absorbed, like needed if you are going to break down the bonds, and energy is released when the bonds are going to be formed. Let's suppose this is me. I need your attention. This is me, let's suppose, okay? And I need to let you something. Let's suppose this is me, okay? And this is my brother, okay? It's just example, man. This is my brother, and he's coming from Saudi after 20 years, let's suppose, okay? After 20 years. Obviously, when I would be I would be going to the, you can say, to take him. So I would be so excited, you know. So let's suppose I'm going to meet him. I'm going to hug him, let's suppose. So obviously I would be releasing energy. So when the bonds are going to be formed, so the energy is released. Remember, when the bonds are going to be broken, let's suppose, Madarka is going to separate me, let's suppose. Like, he doesn't want to look me in this form. Let's suppose I'm hugging my brother. So basically Madarka has to, you can say, provide some energy. Obviously, when the bonds are going to be broken down, so the energy is needed. I would not leave my brother. So you have to require so much energy to break me from my brother, to separate me from my brother. So same goes with the reaction. Remember, same goes with the reaction. When the bonds are going to be broken down, so energy is needed. Energy is absorbed. And when the bonds are going to be formed, so the energy would be released. Simple. It's very simple. It's very simple. Why I'm going to tell you these things, as we have discussed, like when the energy is released, so the reaction is exothermic. When the energy is absorbed, so the reaction is endothermic. Why we are going to introduce this new term? Basically, I told you in the last class, examiner would be asking the definition of exothermic and endothermic on the basis of bond energy. So I am going to tell you the new definitions of exothermic and endothermic system on the basis of bond energy. But before going into that, we need to we need to understand, like, what is bond energy basically. So it may be released, it may be absorbed. If you are going to break down the bonds, it may be absorbed. And if you are going to form the bonds, like make the bonds, obviously it would be released. Simple. So that's why I'm telling you that it depends on the situation. It depends on the situation, right? So okay. Okay. So so how can I tell you the definition of exothermic and endothermic system on the basis of bond energy? So let me tell you something. Let's suppose this is a reaction. This is a reaction. Okay. Let's suppose this is a reaction. As you know that these are reactants. Okay. As you know that these are reactants. And this is the product. This is the product. I'm assuming that this much energy is needed to break the bonds. I am going to have this positive sign. Faryal, can you tell me why I'm going to write this positive sign? Yes, Faryal, can you tell me this? Yes?
I didn't understand.
I don't understand.
Can I answer?
Oh my God. Oh my God.
Sir, can I
Maheen,
answer?
can you tell me? Wait. Maheen, can you tell me why I'm going to write the positive sign? Yes? Yes, Maheen? And Sayyid Muhammad Ahmad, can you tell me this? Fast. Fast. Huria. Huria, can you tell me this? And Hamna Liaquat, can you tell me this? Anaika. Reni. Iba, wait. Umar.
Energy is being
Oh,
absorbed.
exactly. Energy is absorbed. That's why I'm going to represent with a positive sign.
Sir, because it's an endothermic.
Exactly. This is an endothermic. Why? Because I'm going to break the bonds. This is the reactant side. Always we need to break the bonds of the reactants, and always we need to form the product in the, like we need to form the bonds in the product side. Okay, so I'm assuming that examiner would be giving you energy. Let me tell you something. Examiner would be providing you different energies. Okay, then you have to solve it. I'm telling you how you are going to resolve. You are going to solve. Okay, so 50 kilojoules energy is needed to break the bonds. So I'm writing needed to break the bonds. The bonds. And 30 kilojoules energy is released. Energy released to form the bonds. Okay. So what is the difference? 50. Basically, the formula for calculating the bond energy is reactant minus product. Okay, I would be telling you this. Reactant minus product. Remember, reactant minus product. This is the formula. This is the formula. Yes, Adan. This is the formula to find out the bond energy of different reactions. Okay, so as you can see, the answer would be, I'm not going to apply this formula right now. Okay, the answer would be plus 20 if you are going to have a difference 50 minus 30, which is equal to 20. Okay, which is equal to 20. I want to have a difference that is equal to 20, right? 20 is positive. 20 is positive. Overall answer is positive. Overall answer is positive. Overall answer is positive, which shows that the reaction is endothermic, which shows that the reaction is endothermic. Remember, I'm repeating that whenever I would be asking to decide whether the reaction is exothermic or endothermic, so you are supposed to ask, kindly provide bond energies. I would be providing you bond energies. Okay, then after solving that bond energies, then I would be asking, what's your answer after calculating this? Then you would be telling me different values. Then I would see the value. If the final value is positive, so the overall reaction would be endothermic. And if after the solution, the overall value is negative, so the reaction would be exothermic. Remember, this is very important. This is very important. So now, if you ask, sir, you were telling us that you would be having some other definition of exothermic and endothermic systems. So now I'm going to tell you. As you can see this reaction, the energy to break the bond is higher. That is plus 50. Okay, I need your attention. This is very important to know. You will be you will be able to understand, inshallah. I'm repeating. The energy which is required to break the bond is higher as compared to the energy that is released to form the bonds is lower. This is higher. This is higher. This is lower. This is higher. This is lower, right? This is higher. This is lower. If you will see such a situation, then you can say that the reaction would be endothermic. Remember, I'm repeating, if more energy is absorbed, than released, so the reaction would be endothermic. So this is the definition on the basis of Born energy. Remember, if he's not going to ask the definition of exothermic or endothermic on the basis of Born energy, so you would be telling the old definition. But if examiner is going to mention that you are supposed to write down the definition of an endothermic or exothermic system on the basis of Born energy, so you would be telling the same thing. So more energy is absorbed than released. Okay. So obviously, when you will be solving this plus 50 minus 30, so you would be getting overall positive value, which shows that the reaction is endothermic. Okay. Abdul Vase, are you getting my point? Abdul Vase,
Yes,
Shaban, Maheen,
yes.
Madarka, Huria, Hamna.
Yes, sir. Yes, sir.
Good. Mohammad
Yes, sir.
Ahmad. Okay, Madarka, good. Okay. Anaika, are you able to understand?
Yes.
Good. So if I would be asking the definition of an endothermic system, so you would be telling me more energy is absorbed than released. Okay, more energy is absorbed than released. Or you can say the energy of the reactant, is greater than the product. Okay. Then exothermic. Can anyone tell me, after looking at this definition, who can define like what's an exothermic system on the basis of Born energy? Yes. Yes. Can anyone tell me? Ayat, Zubair, Abdul Wase, Adan, Anaika, Faryal, Hamna, Liaquat,
Uh,
Huria.
more energy is released than absorbed.
More energy is released than absorbed, right? Okay. So this is a question from your past paper, how you would be solving this. Okay. Wait. Basically, this is the question. After having the Born energy values, you would be calculating and then deciding what would be the final answer. So obviously, in some questions, you would be asking to tell whether the reaction is exo or endo, right? One question I'm going to do, and then rest of the questions you would be doing, inshallah. Okay. Yes. So what I'm supposed to do, I'm going to add them together in this way, like this. So this is reactant, right? So C2H4 is just like that. This is C2H4. You must know this, how to draw the structure, right? And this is O2, just like that. This is CO2, just like that. Okay, this is H2O, just like that. So 2H2O and 2CO2 and 3O2. So C double bond C, one bond, and you know the energy that is given to you, that is 614 plus CH. How many CH? How many CH? 1, 2, 3, 4. So 413 multiplied by 4 plus O2. O 495 times how many oxygens you have? 3. This is your reactant. Then minus, then I would be solving the product side. CO2, C double bond O, C double bond O. How many C double bond O in one molecule? You will say 2 C double bond O. So how many molecules you have? 2 carbon dioxide. So in total you have just like that 4 C double bond O. So 799 times 4 plus this is OH. This is OH. 467. How many OH you have? This is 1, this is 2, and you have 2 molecules. So 2 into 2, that is equal to 4. 4 into 467. Then you would be solving this, and then you would be telling me the answer. Then I would be telling you, yes. Can you tell me the answer? Yes. What's the final answer? Fast. Fast, fast, fast. Fast,
Sir, is
fast,
it C?
fast. I don't know. Can anyone confirm, please? Yes. Yes. Fast. Oh my God. One is saying B or C. I don't know. Madarka, can you confirm? Iba, can you confirm? Hamna, Liaquat, Huria, and others. Muhammad Ahmad, Shaban,
Sir,
Mahin,
I got
Ibrahim.
C.
I got C. C for cat, right?
Mm-hmm.
Okay. So you people are supposed to confirm. If you're getting the wrong answer, then do let me know. Okay, but this is the question that you have to do.
Got C.
So you would be solving this as well. I would be sending you this right now, and then you would be solving this as well, right? Or you would be still be solving this as well, right? Okay, and also this is also the question related to the bond energy, and then a lot of questions you have. Okay. And this is also the question. In this question, the examiner has already given you the structure, so this is very easy question. Same repeated question. Okay. Repeated question. Okay, so I'm going to send you this, and you're supposed to do. Or so we have completed exo and endo. So the fuel cell is left. Okay, so like might be possible that we would be discussing the fuel cell in electrolysis or in energetics basically. So this is very easy chapter. But when you would be solving the questions, so you would be having some difficulties. So you are supposed to do it first, and then obviously I would be taking a test of that chapter as well as previously I did. So okay, so looking forward, and then I'm going to send you this. Any question?